Hello there, welcome back. Welcome to part 2 of how to make a very quick circuit board. To cut the traces on the copper clad board, hope you can see that, just using a diamond, I think it's diamond impregnated, I'm not quite sure. It's flat on one side and it's got a rounded bevel there. They're very cheap. I think they're about a couple of quid for 5 or something like that, and you can sharpen them up with your Dremel afterwards. So that's the kitty that we use, onwards and upwards. Right, so then it's just a matter of marking out the trace on a board. That's a straight one. Usually I'd use a proper square and whatnot, or mark the edge like so. Or if we've got another component, circular there. So to do straight ones, just use an old plastic ruler. So an idea to keep the speed down. And I'll just jiggle this into position. See that? Curves are a little bit trickier. It's a matter of going round finally. And then there you got it. I used to deburr it with one of those round sort of grindy things, but now clean it up with some wet and dry. As you can see, obviously that one's a lot better, but you can get quite a fine trace, and with practice you can go in between integrated circuit pins and what have you. That's basically the method, nothing complicated. If you do make a mistake, you can always bridge it with an old component lead, solder it in there, and then away you go. Okay, on to the next bit. Right, I've done all my traces just about. I'll have to put a few jumpers in a few places. This output here will have to be jumped over to here. The positive, no, that's the negative rail, we'll have to have a jumper here. But I think that's about it. Oh yeah. Anyway, what I'll do, I'll clean this up and then it'll look a lot better hopefully. Okay, that's it cleaned up. The next job is to go around with a magnifying glass and check out, see that there's no shorts, and then when I've gone over that, I'll go over with a magnifying glass, then I'll go over with a continuity checker and make sure that there's no shorts. But basically that's about it. I can see a few traces there just from up here that need cleaning up. But as you see, it's a little bit tricky getting in between the legs of the op amp, but it can be done. Right, testing for shorts now. I've gone over it with a magnifying glass and made sure tried to make sure there's no shorts. obviously that's supposed to be there. Right, got a short there. Right, I'll just go over it. Right. Well, I've got a short there too. Right, that seems okay. It's just one or two other places I can see where the trace is a bit thin, so I'll go over it again. Right, the last job now is to give it a clean with one of these isopropyl swabs. And then try not to touch it afterwards with the fingers. Right, I'll populate it and then get back to you. I'm checking the circuit as I go to make sure, well, I wanted to try and cut down on mistakes. So basically I'm following the input to the output, as it were. So flip it over. Got a 2 input resistors, one to ground, and then that one goes into the non-inverting input of the op amp, and then from there it's the next morning now. I stopped yesterday. I was getting a bit tired and the light was going and I was making a few mistakes. So that's all the components on there now, apart from the pot. Couple of components mounted on the underside, a jumper, 3K3 and the 100K output resistor. The last thing I have to do, and I've checked all the connections to make sure there's no shorts. The last thing I have to do, apart from fitting the pot, is to check out my ground connections, make sure there's grounds where there should be grounds. And then to do this one-handed, it's not easy. I wish I could find the bloody thing for my tripod. Okie doke. So that's the circuit. And apart from the power supply, checking the ground, so that's it, it's done. So from designing, in inverted commas, to breadboarding and making the PCB, well, not PCB, circuit board, it took what, less than a day. So now all we have to do, finish that and connect it up and see if it works. Okay, I've got it all connected up. I'm testing the highest, what is it, highest pass? I designed it to have a cut off at 300 Hz at the top. So, so that's the pot set to its highest frequency setting, if you get me. We're on about 300 Hz. Oops. And as you see, it's starting to attenuate. So that's its high pass, highest pass band thingy. Oh, where are we? Right, we're on 20 Hz now. I'll just try and alter this. Got leads everywhere. If I turn that, turn that right. I've turned the pot the other way now. As you can see, that's attenuating it at about 20 Hertz even. I'm going up in frequency, 30 Hertz. And we've gone down quite a few dB there.